So now let's first quickly look into the requirements analysis. Requirements come from the user, from the data user of the database, of the information. And that means that the user has some information in mind which he wants to persist in the database management system. And for the database developer, for the information modeler, it's now important to find out what kind of objects are there in the space of the information of the user, what kind of attributes might describe these objects in detail, and what relations exist between the objects, and maybe also which attributes have these relations. And you can collect these information about the requirements in tables, for example, like you see here in this table on the right side. You have some information about a kind of person. You want to somehow model a person. And what is important in your information model is the information about a person number. This seems to be kind of integer, and the length, let's say it's 8 digits long. And also about the person, the name should be modeled. The name should be persisted in the database, and for the name you reserve 30 characters. So this type is named string then. And you would do these analysis of the attributes, of the types for the attributes for all objects you would have in your information model. So you request the user, you as the information modeler request the user what kind of information he wants to save, and then he tells you, oh, I have a person with some attributes, with some properties, and maybe something else, some cars or houses or whatever. And you then have to identify if these cars, houses are objects on their own and what kind of attributes they would have. And then persons might have relations to cars, to houses, and then you also write up these relations as the requirements for your requirements analysis. Second part is the requirements for processing. It's not only the static data model you need to analyze regarding the requirements, you also need to analyze the processing which might be done with the data. Here in this part of the information modeling we will not focus on the processing, but might be important to know which information you request, which updates come into the database, and which reports you might want to produce for your data. What is more important on the technical side is about the qualities and maybe the priorities of the processing. So how many data do you have? What data volumes do you expect in your application? Are there hundreds of persons? Are there thousands of persons? Or are there millions of persons, for example? And also the frequencies of the processing. How often do you execute a certain function, for example? And last but not least, not all users of the database should see the information which is persisted in the database. Some person should have access rights to all information. Some other person should be able to see only a part of the information, only a small view onto the information which is modeled, which is persisted. And that's why you have to think about access rights for different persons or different groups of persons. This leads us then to our conceptual design. So we take the requirements, we take the information we got from the later user, and we try to design our model first. So this is a kind of abstract methodology, abstract because it's not concrete in the tables, not concrete in the database yet. It's first a conceptual design such that you get an idea about the information you would save later on in the database. And the methodology we choose here is the entity relationship diagram. And in the lower part of the slide, you see an example of this entity relationship diagram. Obviously, there are information about an employee saved in the database. The employee might have an employee number, an employee name, and maybe some other attributes as well. And there's also a department the employee works in, and the department also has a department number and a department name. So this is a slide, small view into the methodology, and we will look into detail in the following slides.